While Roger, myself and our colleagues were writing and presenting the material for this series of videos on software engineering, we became very conscious that we were giving you plenty of information, but perhaps not necessarily giving you real-world experiences of the things that we've been involved in software engineering. So we're going to take a few minutes at the end of this series just to share some insights and some experience that we've had in software engineering, as we've shared experiences with so many different software engineers and project managers around the world. So we're going to consider those few questions just now. Roger, what are your thoughts on this question?
Well, there's no question in my mind, Phil, that the key issue is looking in the mirror. You have to determine where you're strong and where you're weak. And until you do that, it's really very difficult to improve software process. The real issue occurs when we examine organizations of different sizes, because looking in the mirror differs depending on whether you're a large software group or a small one.
I think you're right. For a small group, it's fairly straightforward to get together in a meeting, share some time together, and ask each other about the difficulties that you face on a daily basis. With a team of, say, 100, 200, 300, 1,000 software engineers, how do you go about working out how you should move forward with software process? That's the difficulty, isn't it?
I think it is. There are a couple of problems with very large organizations. First, the looking in the mirror part. With a large organization, you really do have to do a formal assessment of some kind, and normally that occurs from outside the organization. A consultancy of some sort does an assessment of software process. They come in with a report and recommendations, but the real difficulty is how do you implement the recommendations? A lot of very large organizations try to do that top down. They try to impose changes from the top. It's been my experience that change works better with software people if it comes bottom up.
Absolutely, I think you're right. So often we have things imposed on us, I think, certainly from my experience. And often something that's kind of self-grown from within the group can be so much more successful because the team have a kind of a buy-in, to use that management speak, which we're also reluctant to use. But they have a buy-in, they're excited about the change because it's something that they've instigated. So, should we roll out the funeral car yet?
The answer is yes and no. There's no doubt that structured methods have slowly kind of waned in their use throughout the industry. But that's not to say that they still don't have benefit. And it's also not to say that some groups in some places still use them. They're a relatively simple, very straightforward way to represent the transformation of information as it moves through a system. They're easily understood by many different stakeholders, and they provide some benefit. But I do think as time passes, they're beginning to disappear.
I think you're right. I mean, it was certainly a debate we had when we were considering the curriculum for this particular series. Should we put in something on conventional methods? But in my experience working with both industry and with universities, we still see a fairly decent take-up on particularly SSADM in, I suppose, a fairly niche market in terms of perhaps defence and avionics industries. But it's still a very important methodology to be used, and the techniques that are there, as you say, are important. I think the other aspect of it is, from a student's point of view, they'll say, absolutely, these methods aren't particularly wide used anymore. But I think the background in engineering that they gain from a fairly strict methodology like SSADM is perhaps different to that you gain from UML, where you're provided with a range of different techniques, but not necessarily the process framework that sits around it.
It's a funny thing. In one of the recent editions of my software engineering book, I finally decided to extract all of the structured methods material, or at least a significant percentage of it. And I will tell you that I got some hate mail.
Oh dear.
Yes, people said, how could you possibly have done that? I made the decision that it just wasn't current anymore. But then I began to have second thoughts. Now, I haven't put it back into the book, I'll admit that. But you know what? There still is some merit. I agree with you. And it may have been unfair to take it out of the book.
I think this is another one of these pragmatic approaches, isn't it? So often when we're in software engineering, we can be kind of deluged with so many different techniques. And to me, the important thing is that we look at our local situation, we look at the project on which we're working, and we make sure that we take those techniques which are going to work best in our situation. To me, it's unlikely that many projects will actually use the entire range of UML diagrams. Each of them serves a specific purpose, and they can be used to help you in certain situations. But to use them all, to me, would almost certainly be overkill.
Yeah, the common sense approach in modeling in general is to keep it as simple as you can. The ideas associated with agile modeling or lean modeling really all go toward that. There's absolutely nothing wrong with UML. In fact, it's a very powerful modeling language. But that doesn't mean that you have to use every diagrammatic form. Nor does it mean, interestingly, that you have to be absolutely, precisely, syntactically correct when you use those forms. Now, if you're using tools, there's no problem. They'll help you with the syntax. But no less, you use the model types that best allow you to explain things to those that will follow and move on from there.
I think you're right. If we take, you could probably just list a few diagram types and say, these are the key ones. If we use use case diagrams, class diagrams, sequence diagrams, activity diagrams, perhaps, those are the 4 key ones that are really going to help you to understand what the system should be doing, the classification system, the behavior, and the dynamics of the system that you're trying to build.